This video and other videos for CompArc 211 can be found here at Sarai Studies. Link is in the description box below. Here we're given some truth tables, and the idea is that we can find a formula for these truth tables, and there's three ways to do that. We can either express the formula as a sum of products, as a product of sums, or use a K-map to get the simplest sum of products form, the simplest formula. So this video is going to be separated into two parts. The first, I'm going to teach you how to actually set up the K-maps from a truth table given different amount of inputs, and then in the second part, I'll teach you how to actually get the formula using the K-map that you just set up. No matter what the truth table you're dealing with, a K-map always starts off as a box, and the easiest thing is to find out how to split it. You just look at your truth table, count the number of rows. Here we have 1, 2, 3, 4 rows, so you split the box into 4. So the number of boxes inside your K-map is the same as the number of rows. In other words, it's the same way that we calculate the number of rows for a truth table. It's 2 to the n, where n is the number of inputs. So if we have 2 inputs, it's 2 to the second power, which is 4. So we'll have 4 boxes. Then you want to do a little line, and this is where your inputs are going to be. So our inputs are A and B. Remember that the last column in the truth table is always your output column. In this case, we call it F. What goes above and below here are our inputs. So in this case, we could do A and B. You can switch these. B could be here, A could be here, whatever you feel like. And then what goes on these axes are all of the possibilities of A and B, what they can be. For example, let's look at A. If you go through, the first thing you see that A can be is 0. So then you write 0. Then you cross that out. You move on to the next. You say, oh, A can be 0, but I already knew that. I already wrote that. So you disregard that. You move on to the next. Oh, A can be 1. So you write down 1, and then you cross it out and you move on to the next. Oh, A can be 1, but I already know that. I already wrote it down. So you move on to the next. Oh, there's nothing. So you're done with all of the things that A can be. A can either be 0 or 1. Here, B can either be 0 or 1. So again, you go through B. The first thing you see is 0, so you write down 0. Then you move on to the next. Oh, B can also be 1, so you write down 1. Then you move on to the next, and you're like, oh, B can also be 0, but guess what? You already said that. You have that written down, so you disregard that. Move on to the next. Oh, B can also be 1, but you already said that, so you disregard that. Move on to the next. Oh, there's nothing. You're done with this column. Now, this way of going about finding the axes works perfectly fine when you have a 2-input K-map, but after that, there's one little thing we have to take care of because of this little rule that we have to follow, and I'll mention it when we get to it, but keep that in mind. Now, to fill in the K-map, you start box by box. In this box, you're looking for when A is 0 and B is 0. When A is 0 and B is 0, the output is 1, so you write 1. For this box, you're looking for when A is 0 and B is 1. Get it? Here, this is B. Here, this is A. So when A is 0 and B is 1, the output is 1. For this box, you're looking for when A is 1 and B is 0. A is 1 here, B is 0 here, the output is 0, so you write 0. For this box, you're looking for when A is 1 and when B is 1. A is 1 here, B is 1 here, the output is 0, so you write 0. And that is how you set up your K-map for a 2-input truth table. As always, we start with the box, then the question is, how do we split it? Well, that depends on how many rows you have in your truth table. Here we have 8 rows, so we're going to split our box 8 ways. Now, you might be like, wait, why couldn't you split the box like this with 4 columns and 2 rows? That's still 8 boxes. And you can do that, but depending on how you split it, this is a 4 by 2, so 4 rows, 2 columns. This is a 2 by 4, 2 rows, 4 columns. Depending on how you split it, the order of your inputs, where they're placed, matters. Like here, it doesn't matter because either way, B and A, they have the same number of possibilities. But since here you have 3 inputs, it will look something like A, B on one side and then C on the other. And the reason we put C here is because it's by itself. You want to give it the lesser of the space. So if you had 4 columns and 2 rows, then the order would be C down here and A, B over here, because C can only be 2 things, so you want to give it the lesser of the space. So that's these 2 right here. While here, AB has 4 because it's double, it's bigger. There's more of them there. So let's go ahead and find all of the possibilities of A and B. So we're looking at these 2 columns over here. Let's start with the first row. A and B are 0, 0. So that's one possibility that A and B can be. So we write that down. Then we move on to the second row. Oh, A, B can be 0, 0, but guess what? We already have that written down, so we can disregard it and move on. These are all supposed to be unique values. So I see, oh, A, B can be 0, 1, so I write that down. Then I move on to the next. Oh, A, B can be 0, 1, but I already have that down as a possibility of A and B, so I disregard it and I move on to the next. Oh, A and B can be 1, 0, so I write that down. I see 1, 0 again, but I already have that down as a possibility, so I can disregard it. Then I move on to the next. Oh, I see that A and B can be 1, 1, so then I write that down, and then I move on to the next. Oh, A, B can be 1, 1, but I already have that down, so I disregard it. I move on to the next. Oh, there's nothing else, so I'm done with all of the possibilities of A and B. So basically, A and B can either be 0, 0, 0, 1, 1, 0, or 1, 1. Then you move on to find out what can C be. Well, you go to the column, you go to the first one, C can be 0, so you write down 0. Great, move on to the next. Oh, C can also be 1, so you write down 1. Then you move on to the next. Oh, C can be 0, but we already have that. We wrote that down, so we disregard it. Then you move on to the next. Oh, C can be 1, but we already have that. We wrote that down, so you move on to the next. And then you notice the pattern. We already have these, so we just disregard. There's nothing new. So at the end of the day, C can only ever be 0 or 1. Now here's one of the rules that you have to follow. The difference between every column and every single row should be 1 bit. In other words, this is a bit, this is a bit. Here, there's only 1 bit change. Here, this is a bit, this is a bit. From here to here, this bit and this bit, the only one that changed was this one. This went from a 0 to a 1. This one stayed the same. And that's the rule. Only 1 bit can change. So the problem is, you see here, this changes from a 1 to a 0, and this changes from a 0 to a 1. So it's breaking the rule that only 1 bit can change. So what should come after this should be something that's only changing by 1 bit. And this one's already fine. So how about you just try switching these two? And now you see that from here to here, these are the same. You only have 1 bit changing from 0 to 1. So now the rule that between every single row and every single column, there's only a 1 bit difference is satisfied. Now, how do we fill in our table? Well, go box by box. Here we're looking for when A and B are 0, 0, and C is 0. So AB being 0, 0, and C being 0, the output is 0. See, it doesn't matter what they call the output. The last column in your truth table is always your output column. For this box, we're looking for when A and B are 0, 0, and C is 1. So AB being 0, 0, C is 1, the output is 1. For this box, we're looking for when A and B is 0, 1, and C is 0. AB is 0, 1 here and here, but C is only 0 here. So then the output we're looking for is here at 0. Here we're looking for when AB is 0, 1 and C is 1. So AB is 0, 1, but C is 1 here, so we're looking for the output here is 1. Here we're looking for when AB is 1, 1 and C is 0. So AB is 1, 1 right here, but C is only 0 here, so we're looking at this output is 0. Here we're looking for when AB is 1, 1, but C is 1. So A and B are 1, 1 here, but C is only 1 here, so we're looking at this output, which is 0. Here we're looking for when AB is 1, 0 and C is 0. So AB is 1, 0 here and here, but C is only 0 here, so we're looking for this output is 0. Then we're looking for when AB is 1, 0, but C is 1. So AB is 1, 0 here and here, but C is only 1 here. So the output that we're looking for is 1. And that's it. That's your K-map. Now let's try doing one for a 4-input truth table. As always, we start with the box. How do we split it up? We count how many rows we have in our truth table. We have 16 rows, so we're going to split this up into 16 boxes. So we have a 4 by 4, 4 rows and 4 columns. Now hopefully you notice a pattern. Here we have an even amount of inputs, it's 4. If we scroll all the way up, this was also even. It doesn't matter the way that you split. The way that you split is not going to affect the order of the inputs, whether you put 2 above or 1 at the bottom, because they're always an even amount, so you can always evenly spread them out, top and bottom. But when it's an odd number of inputs, then you have an odd number of inputs, so you don't know whether to put 2 here or 1 there. The way that you split does affect it, because again, we're doing a 4 by 2, but we could have done a 2 by 4, so 2 rows and 4 columns, and then because of this, it affects the order of our inputs, so A, B would go here and C would go there. So the way we split only affects the order of our inputs if it's an odd number of inputs. If it's even, it doesn't matter the way we split. Either way, it's a 2 by 2, you can't change that. Here is a 4 by 4, you can't change that. So we're going to put our little line, and then again, we have 4 inputs, A, B, C, D, so we just put 2 at the bottom, 2 at the top. As always, these axes represent all of the possibilities that A and B can be. So we're going to look at these 2 columns together and ask yourself, what can A and B ever be? Well, the first thing I see, it could be 0, 0, so you write down 0, 0. I skip all of these because it's the same thing. I move on to the next thing that I see that it can be. It's 0, 1, so I write down 0, 1. I skip all of this. The next thing I see that's new is 1, 0. I skip all of this. The next thing I see that's new is 1, 1, and then I don't see anything that's new or different after that. Then for these, what can C or D ever be? So I'm going to be looking at these 2 columns. C and D together can either be 0, 0, so I write down 0, 0. It could either be 0, 1, so I write that down. It could either be 1, 0, so I write that down. And finally, it can be 1, 1, so I write that down. If I continue, oh, it can be 0, 0, but I already have that down. Continue, oh, it could be 0, 1, but I already have that down. And if you continue all the way, you'll see that all of these are just repeating values that we already know C and D can be. Now, again, no matter what K-map you're using, you always have to follow the 1-bit difference rule. The difference between every single column and every single row should be 1 bit. So again, if you look over here, this bit changes from a 1 to a 0, this bit changes from a 0 to a 1. Here there's a difference of 2 bits. The rule is we could only have 1 bit change. So you can simply just switch these right here. And now you have it that from here to here, there's no change, it stays the same, but this bit changes to be 1. And that's fine because from this row to this one, the difference in bits is only 1. So the rule is satisfied. Same thing is happening over here. This bit is changing to a 1. This bit is changing to a 0. That's a 2-bit difference. We can only have a 1-bit difference. So just switch these two here. And now this bit changes to a 1 and this bit stays the same. So there's only a 1-bit difference between the columns and the rule is satisfied. Now you can fill in your table. Let's start with this box. Here we're looking for when A and B is 0, 0 and C, D is 0, 0. So in other words, when they're all 0, the output is 0. So we write down 0. Here we're looking for when A, B is 0, 0 and C, D is 0, 1. So A, B is 0, 0, all of these, but C, D is only 0, 1 here. So we're looking at this output that is 0. So we write down 0. Here we're looking for when A, B is 0, 0 and C, D is 1, 1. So A, B is 0, 0 here. C, D is 1, 1 only here. So we're looking at this row, the output is 1. Here we're looking for when A, B is 0, 0 and C, D is 1, 0. A, B is 0, 0 in all of these cases. C, D is only 1, 0 here. So we're looking at this row and the output is 0. Here we're looking for when A, B is 0, 1 but C, D is 0, 0. So A, B is 0, 1 in all of these cases, but C, D is only 0, 0 in this case. So we're looking at this row and the output is 0. Here we're looking for when A, B is 0, 1 and C, D is 0, 1. So A, B is 0, 1 in these cases and C, D is 0, 1 in this case. So we're looking at this row, the output is 0. Here we're looking for when A, B is 0, 1 and C, D is 1, 1. A, B is 0, 1 in all of these cases. C, D is only 1, 1 right here. So we're looking at this row where the output is 1. Here we're looking for when A, B is 0, 1 and C, D is 1, 0. A, B is 0, 1 in all of these cases. C, D is only 1, 0 in this case. So we're looking at this row where the output is 0. Here we're looking for when A, B is 1, 1 and C, D is 0, 0. So A, B is 1, 1 right over here, but C, D is only 0, 0 here. So we're looking at this row where the output is 1. Here we're looking for when A, B is 1, 1 and this time C, D is 0, 1. So again, we're looking at these and we're just looking for when C, D is 0, 1 that's here. So then we're looking at this row where the output is 1. We're still in the section where A, B is 1, 1. So we're here and we're now just looking for when it's 1, 1, but the output is 1. We're still in this section, but this time we're looking for when it's 1, 0. So now in this row, the output is 1. Then we move on to when A, B is 1, 0. That's these right here. And then we're looking for when C, D is 0, 0. So that's this one. So we're looking at this first row, the output is 0. We're still where A, B is 1, 0. So over here, now we're looking for when it's 0, 1. The output is 0. Now we're looking for when C, D is 1, 1. That's over here. So in this row, the output is 1. Now we're looking for when C, D is 1, 0. That's in this row where the output is 0. Now in part 2 of this video, I'll show you how to get the formulas using these K-maps. I'll see you in the next.